in your class, and you want to make sure that you do a good job on your next test. But who wants to study more than you have to study, right? Like you want to do I'm sure we all want to do the bare minimum that we need to do in order to get the grade that we want to get. So maybe a good way you could do that is you could track how long you spend studying every time you have some kind of a mastery assessment, and you can plot that information on a scatter plot. So what kind of a trend or a relationship do you notice that connects the amount of time that you studied to the grades you get on the test? Is there a relationship there at all? Yeah, there's a relationship there. Would you say it's a positive relationship or a negative relationship correlation? It's a positive one, because as the amount of time you spend studying increases, typically there is a general increase in your grade. Now, in math, we use something for a scatter plot, because the data isn't perfectly linear, right? For example, this person here, here you studied for an hour. Those are decimals, by the way. I think it's easier to see on your side. But one time I got what it appears to be like maybe a 78. And another time I studied for an hour, I got an 85. So it's not an exact science, of course. You can get a pretty good general estimate, but it's not going to be perfect, because in real life, numbers aren't perfect, right? They're never, well, shouldn't say they're never nice and round, but normally they're not. So in the sciences, we use something called a line of best fit. So this first little blank that you guys have to fill in right here, your calculator, let me preface something. So in math, or in 8th grade math, all you guys need to know how to do is just kind of look at that scatter plot and kind of eyeball where the middle is and get like a pretty decent estimate. So that's a pretty good line of best fit, because it's pretty much in between the lines, or in between the coordinates. You've got the same number of coordinates on the top as you do on the bottom. So again, this is called a line of best fit. It means that it's a line that kind of goes through the middle of your data set. And why is it called a line of best fit? Because it kind of fits in with the data. So again, in 8th grade, all you have to do is kind of eyeball it and estimate where that line goes. In algebra, I am going to teach you guys early next week how to construct your own line of best fit, because in algebra, it's actually pretty cool. The graphing calculator can do this little trick where it basically measures the distance between every coordinate, and it can figure out exactly where the middle is for you. So that's kind of cool. And it will provide you with an equation. So the equation for this particular line of best fit is in slope-intercept form. So there's my B, there's my beginning point, there's my y-intercept, which corresponds right there on the y-axis. And what that coefficient, do we remember the word coefficient? It's that number in front of the x. Remember, that's also called our slope. It's also called rate of change. We like to give 9 different words to exactly the same crap. So what that means is that for every hour that you study, so as your x increases, your score will likely go up by about 5.4 points as your x increases. So as your time studying goes up, you go up about half of a letter grade. But what grade, according to this equation, what grade would you get if you didn't study at all? A 76.4, right. That's what that y-intercept is about. This tells you, hey, even if you don't study, at least based on your history here, if you don't study at all, you'll still pretty much get about a 76. And then for every additional hour that you study, that grade will go up about half of a letter grade. So if you were to study for 2 hours, according to that scatter plot, about what grade would you expect to get? And this is a little bit tricky, because I gave you this question specifically to kind of make you think. So 2 hours, where's 2 hours on the graph? Right here, right? So which estimate, what do we use to figure out what our grade would probably be? So I heard one person, and it's good that you kind of have a question in your voice. I had one person that said 80, so I assume they're looking at that coordinate right there. Is that the coordinate we should use to make a prediction? No. Oh, good, because I hadn't told you that yet. Yeah, the whole point of that, pun intended, of that line of best fit is that it goes through the points, and that is what you're going to use for your estimate. So you are not going to use this to predict about what your grade would be. You're going to actually use the line itself. That's why it's there. So if you were going to study for 2 hours, we would go right here to the line, and I'm going to say 87-ish, kind of halfway in between 85 and 90. I guess I should really do that more mathematically, right, and do the little squiggly equals. So approximately 87 is what you could probably estimate based on the line of best fit. So don't use the coordinates, use the line of best fit. Use the line, okay? That's what it's there for, to make a prediction. You can also use that line of best fit to figure out how long you should study if you want to get an A. So what's the lowest A we can possibly get? What's the lowest A possible? 90, right? So what I would do to figure out if I wanted to get an A, what I would do is I would zoom in over here. So if I want to get an A, I would look at where the line hits about in order to get an A, and about how much am I going to need to study? Yeah, about 2.5 hours, exactly. So you can use it to predict either way. You can use it to predict what outcome you would want to get and see how much you need to study. Or you could say, hey, well, if I want to study, if I only feel like studying for 2 hours, about what grade could I expect to get? And if you're a person that just doesn't like graphs, like I'm a visual learner, so I really appreciate graphs, but if you're somebody that really just doesn't like them, another kind of cool thing that you can do with this equation, I'm going to erase this for a second. You could just take the equation for the line of best fit, and again, I'm going to show you how to use the graphing calculator to actually get this equation line for you. And what you could do is you could just substitute 90 in for y, and then you could just solve that equation and see what would x have to be in order for y to be 90. And yesterday we did it, and once we isolated that variable and subtracted 76.4 from both sides and divided, it ended up being about the same. It was like 2.56 or something like that. It was pretty close. So whether you use the graph, thank you, honey, or whether you use the equation, you can use it to make predictions about how you might do. And there is actually a word for that whenever you're using the line of best fit for a value that is inside of the graph. You're doing something called interpolation, okay? It's interior, I guess, is where that prefix comes from. So any questions about what you're gonna, about how you're gonna use that line of best fit? All right, the last thing you can use that line of best fit for, anybody not okay if I slide down? And I got one more quick example and then I'm done talking to you. Okay, another thing that you can use it for, in addition to interpolation, that's values that you see on the graph, you can also use it to make predictions for things that do not appear on the graph. And instead of interpolation, that is called extrapolation. So I guess it's stuff that's extra, not on the graph. And this will be an example of what you'll be asked to do. So I guess this chick is catching catfish, and there's a clear relationship between their length and their weight. Obviously, if the catfish is longer, you assume it's probably going to weigh more. So she's drawn herself a nice little line of best fit right here in the middle. But it's asking, how would you predict, or how much would you predict a catfish that's 32 inches would weigh? Does this graph go all the way up to 32? It does not. That's why this is called extrapolation, because you've got to make a prediction based on where the graph will probably be. And in order to do that, friends, you're going to use our old friend slope. So see what I would use, and you could use either two coordinates that you want, but I'm going to use these two. So I'm going to look at my slope between those two coordinates. Now, before you answer this question, look carefully. What is my rise?
3.
Are we sure it's 3?
No.
I see 3 boxes. Where'd you get 9 from? Okay, so each of these guys, are they going up by 1? So once we get into real life data, be careful, because a lot of the time they change the scale on you and the boxes don't necessarily represent 1 anymore. Okay, so these boxes are increasing by 3 every time. So yes, sir, you're absolutely right. So your rise is 9. Now your x coordinates are just going up by 1. So your run is 4. Exactly. So write yourself a little note. Be careful on that scale, because a lot of the time they'll try to trick you, especially with real life data. So be careful. So if my rise is 9/4, or my slope, I'm sorry, is 9/4, I can use that same rise over run. If I went up 9/4 again, that'll get me right over here to 32. So about how much would we expect? So you just add on another slope, basically. So yeah, see? Correct, exactly. So if I go up 9/4 again, that lines up with 32, which is what the problem was asking me for. And then so how much would you expect a 32-inch long catfish to weigh? About 37. And you can tell visually that it definitely works. If you extend that line, like it lines up perfectly. So you would expect that catfish to weigh approximately 37. And again, this is just an estimate. It's not perfect. Data science never is. You can't, get 100% sure that you're right, but this will at least get you a good estimate. So those are the 3 different ways that you're going to use a line of best fit today. These lines where it might say, you'll use interpolation, where it'll say, hey, if X is this, what's the Y value? You're going to have to eyeball it and make your own line of best fit. Delta math is really not too petty about that, because if you're just eyeballing it, it's not going to be perfect. So as long as your line of best fit is pretty close to the center of the data, Delta math will select it. And then you'll have some where you're going to need to make a prediction based on a point that is not on the graph using that extrapolation. So